All right, good morning again, everyone. Now it's Tuesday the 4th. Just want to make sure you're watching the right video for the right lesson. My name is Mr. Murphy, and this set of video notes will be for anybody who is taking the non-honors geometry class for any of the teachers listed here. So make sure you have a notebook handy so you can jot this down just like you would if we were meeting in person. Continuing along with our algebra review that we do for the first week of geometry, we're going to touch on something else that you've probably had a lot of experience with. We're going to be looking at solving multi-step linear equations. That'll be kind of taking what we did on Monday and taking it just a little bit further here. Okay, so if you need to refer to this chart, this steps for solving a linear equation, feel free to pause, feel free to rewind the video and whatnot, but this is pretty much what you're going to consult as you go through it here. All right, simplify. If we see parentheses, we tend to want to get rid of those first, or combine any like terms if they're on the same side of the equal sign. Number 2, that says, okay, you've got variable terms on both sides of the equation. We need to move one or the other to get them together. Same thing with non-variable terms. Number 3, this just says that you want to end up with an equation that has just a variable term on one side and just a number on the other side here. That gets you a little bit closer to what you need, and these are the different scenarios that can come up in that. The last step, please be aware the directions are going to ask for this each time in the notes. It's not something that students like to do, but there is a lot of value to checking your answer. It really could save you from getting a question wrong, because you'll notice it doesn't quite go as expected when you plug it in. Okay. I'm going to try to give you a little bit of a variety here. So again, make sure you're jotting these equations down on a sheet of paper, ideally in a notebook, labeled by day and date, and then going through it as well. For those of you that might feel a little bit more confident with how to do these equations, you could always skip in the video to where the solution is just to see if you got the same thing. But still, don't forget to check it. We'll take you through how to do that. Okay, this might be overkill. Some students still find it useful to draw a little wall down where the equal sign is. That's telling us that for the time being, the stuff on the left side of the equation, all that stuff can, kind of mingle together as needed, but the 5 is not going to be coming into play all that much yet. So if we consult our steps here, I'm just going to go back to it here. We don't have any parentheses, therefore no distributing, but we do have some like terms we can combine. Notice we've got an x term here and an x term there. They're both on the same side of the equal sign, therefore we can put them together. So -8 plus 9, that's going to give us a 1, and they were both x terms, so we're going to have a 1x. Look for any other like terms, and you won't have to look too hard. You'll see that we've got these two values, which are both numeric terms. Use a calculator if you need to, but we would be doing -22 plus 13. You combine them using whatever sign, positive or negative, they have in front of them right now. So -22 plus 13. Don't do it in your head if you think you might make a mistake, but that's going to combine to give us a -9. All right, so all that left side simplified down to this. Now we're just going to bring down stuff we haven't dealt with yet. So we've got an equals 5 still. Okay, following that list still, step 2 says we want to get variables to one side of the equation. Well, this equation only has one variable in it, so we can probably leave that where it is right now. But it also says we want to get the numerical terms to the side away from the variable, which means we're going to have to move this over to be with the 5. here's where that concept of inverse operations comes into play, which you've probably done plenty of. We can't just do -9 added with 5. If we're moving this over to the other side, we have to do the opposite of that. The way I think of it is, if you use the sports analogy, is think of this player is going to the other side of the court or the field to play for the opposite team. Therefore, he or she is going to swap from their given jersey to the new jersey. Not the state, but you know what I mean. Okay, being consistent, like a scale, you want to do the same thing to both sides. All right, and then you'll see these are going to go away. We have the 1x. If you didn't bother putting the 1 and you just left it as x, that's fine too, which is probably what I'm going to do here in a minute. Now, easy peasy, 2 positive numbers added together just gives us a nice value of 14. So technically it's fine to leave your answer like this, but like I said a moment ago, 1x is the same thing as x. Therefore, we get our solution to this equation of x equals 14. Most of the time you're going to get an integer solution, but occasionally you could end up with a fraction or a decimal. We'll cross that bridge when we come to it. Now for everybody's favorite part, yes, they want us to check it, but hey, nothing wrong with being absolutely sure that our answer is correct. This may seem like a wasted step, but I like to rewrite the original equation. That way I make sure I'm not missing any pieces. We're going to do some substitution just like we did on yesterday's notes. This time around, we're going to take this x value that we got, and we're going to have to substitute that in wherever you have an x. Now, technically, you could simplify this before you substitute it in, but just as a habit, I like to substitute from the beginning. I'll try to color code this as we go. Anything in blue is still going to be there, but now I'm swapping out the x's and replacing them with 14, which is what we got previously. Okay, I would recommend doing this in pieces. The more we try to put into a calculator at once, the more likely people are to make a mistake. Okay, so we can multiply these two things together right here. Easy peasy. The minus 22 is just going to drop down for now. Looks like we got some more multiplication that we have to do. And now for the equals 5 part, just to be on the safe side, this is what I probably should do. I'm going to put a little question mark up above that equal sign, because we are checking to see if this side is going to end up equaling this side. We're not going to know that until we do 1 or 2 more steps. We don't just want to assume that our answer is always going to check out and have things work out properly. The whole point of doing the check is to see if maybe we made a mistake somewhere along the way. Okay. Again, you might be able to do this all in one step, but I'm going to do it in pieces just to be on the safe side. So you're at -112 and you go 22 deeper into the negatives. So those two together will give us -134. Let's combine these. Thankfully, both of these are just positive numbers. So they're going to combine to a good old 139. Let me keep that question mark up there just to be sure. Sometimes students like to stop right here because, at least in their head, they know, okay, this is going to check out. But to officially show that your answer checks out, you need to make sure you combine these last few things. -134 plus 139, thankfully, is going to give us 5. And when you bring down this equal sign and this 5, you will see that with our solution plugged in, we got 5, which matches what the original equation was supposed to work out to. Therefore, this checks out, your answer is correct, and you have all the proof there to back it up. Okay, great. So it'll be a similar procedure. The only thing that'll change is occasionally they're going to mix up what kind of steps you need to go through. Okay, peering back at the list for a moment, we're still going to have to simplify part of the equation. But this time around, we have parentheses, which means we're going to need to do some distributing. Which means, looks like this 5a is going to kind of wait for its moment to shine. We're just going to bring it down, and we have to break down these barriers. Here we have to distribute to get rid of those parentheses. So when we do that, that's going to give us 3a, and then 3 times 2 will give you 6. This stuff right here, by the way, that's just going to come down. So the equals 22, that's just kind of waiting around for everything else to settle down. Okay. Now we have something similar to what we had in number 1, whereas we want to see if we can put anything together that's on the same side of the equation. Here's that little wall for people that prefer to draw it. Looks like the 22 is still hanging out by itself. And then over here, we've got 2 a terms right next to each other, which is very nice. Somebody had 5 apples and then they pick up 3 more. Obviously now they're going to have 8 apples. But the 6, we really can't do anything with it yet. Therefore, we're going to bring that down as is. Just keeping track of what changed from step to step and what just got brought down. All right, we're getting there. If you're going by the steps, you know, it says you want to try to get the variables on one side. Well, once again, we only have one variable, which means in order to get this whole thing all by itself, we need to move the 6 out. Now, and we're going to do that the same way we got rid of the -9 up here by doing the opposite. Inverse operations, we're going to subtract that from both sides. Now, if you wanted to draw this wall again down here, that's fine, because it would show that you're doing the same thing on both sides of the wall, or whatever you want to call it. Those are gone. And then this will be easy peasy, hopefully, because they'll just combine to give us 16. Okay, we're just about done getting our solution. Notice we still have an 8 on that a that we have to get rid of. We didn't have to do this step in the last equation, but I'm sure you've done it plenty of times before. Right now, 8a, that's saying that 8 and the letter a are multiplying each other. So you think more inverse operations, we're going to use that list as need be, because it says here, do the opposite operation of multiplication or division. So in this case, the opposite of multiplication is division. And once again, we're going to get a nice answer, because 16 divided by 8 just gives us 2. Another nice integer answer. Great. But wait, there's more, because now we got to make sure we check it. It'll help us figure out if we made a mistake. Okay. So once again here, if you want to rewrite the whole equation, go ahead. I might go a little faster through this one, but you can pause and rewind as needed. Wherever there's an a, we're going to substitute in 2. So let me try to color code that again. I know I'm missing a few things, but they're going to go in now. So swap out a, put in 2, swap out a, put in 2. This one actually might be fewer steps to crunch out than the previous one, but oh, here we go again. Don't forget that little question mark up there. All righty, so easy enough. That'll give us 10. Here, you can do this in multiple steps, or you might be okay trying to do this in your head. 2 plus 2 is 4. So I'm just going to jot that up here. And then 3 times 4 would make this whole thing work out to 12. Here's that little question mark again, because hopefully we're going to be able to prove that things work out. 10 plus 12, thankfully, is going to equal exactly what was on the right side of the equation. Therefore, plugging in that solution, that gives us equal values here and here. Therefore, this checks out. And for any of you that might not be totally comfortable with the check, you're thinking, well, how would I know that my solution is incorrect? Well, what would happen is when you plug it in, let's say, for instance, you got A equals 3 instead, plugging 3 in here and here and working it all out, you'd still have 22 here, of course, because that was taken from the beginning. But if you plugged in something other than 2, you would get a different value right here. You'd come out with 22 here, but maybe like 28 over here. If these two values at the end do not match, that means that our solution may be incorrect, or maybe we crunch something out incorrectly here. So just to give you an idea of what to look for. All right, moving right along. Still asking you to check. Still consult that list as much as you need to here. Okay. Number 3 is actually similar to number 2. The only difference is we've got to make sure that when we distribute, we're treating this 2 as a negative 2. I'll get to that in just a moment. Here's our 8x, and let's go through and distribute. Negative 2 times x will give us negative 2x, and then negative 2 times positive 3 will give us, see, I almost made a mistake there. You could have put it as plus negative 6, or you could just put minus 6 if you want there, though. I don't really like how this is written right now. It may be a little confusing, so let me just rewrite that. And we still got the minus 12 over here. All right, sorry about that. Hopefully it's pretty legible now. Okay, so with all that, we're going to use the same sort of steps we relied on before. Don't do anything with the 12 yet. That's waiting for everybody on this side to settle down. It also looks like the minus 6 can't combine with anything because these other terms over here with it are x terms, which means I'm going to bring that down. But here it says maybe a doctor ordered 8 x-rays, but he decides he doesn't need 2 of them. It's the first thing I could think of that starts with x. So you're left with the doctor only ordering 6 x-rays. All right. From here, you're probably getting into a rhythm. This is our only variable term, which means to get that by itself, we got to move this over to the other side by doing the opposite again. So opposite of positive, or excuse me, opposite of negative 6 is positive 6. Those are going to cancel out. We're left with 6x equals 18. And then we're going to finish it the same way we did the previous problem here. This says 6 times x. The opposite would be to divide by 6. And we get another very nice answer of x equals 3. Nice integer. Okay, picking up the pace again, ladies and gentlemen, but feel free to pause this video or rewind it as much as you need. We got to now check to see if our answer of 3 is correct. I'll try to color code it again if that makes it easier for students to follow. Okay, same deal. I'll try not to waste a ton of your time. These will multiply out to 24. If you want to do a couple things in one step right here, that's fine, but certainly take it in steps if you're more likely to make a mistake. So 3 plus 3 would give us 6 inside the parentheses. 6 times negative 2 would give us negative 12. Forgot my little question mark again because I don't want to assume anything. All right, and then finally bringing it all together. You don't do anything with this. That just is what it is. Then 24 minus 12, thankfully, that's going to give us a value of 12 as well. Therefore, plugging in a solution of 3 had this work out to 12, just like the original equation did. Great. Fantastic. Okay. They're not necessarily going to get tougher now. They're just going to get different here. So for instance, these next few have variable terms on both sides of the equation. So on one hand, there's no parentheses in this one, but on the other hand, we got those variable terms on each side here. So if you were to consult the list, remember the list of steps to solve these says you want all the variables on one side, you want all the non-variables on the other side. There's multiple ways you can do this. So if you don't do it exactly like me, there's still a good chance you'll get the correct answer. So what I'm going to do is I think I'm going to start with the variable terms. You could either work on moving 8x over here or moving 4x over here. Each way will work as long as you're using inverse operations or opposites. I'm going to move the 8 over here. So the thing is, right now it's a negative or a minus 8x. And if I want to move that to the opposite side of the equation, I have to use the opposite sign. And then you want to add it to both sides because you want to keep things fair and balanced. That gets rid of those. We still have the 7. And now 4 and 8 together is just going to give us 12 x's. But then we've got this minus 17 that hasn't come into play yet. All right, so far so good. Now this is the only variable term we have. And the goal is once you get it down to one variable term, you're going to try to get this whole thing by itself, which means the next order of business is going to be to move the 17 out. Same deal though, inverse operations. And we're getting some familiar pieces. Last but not least, this says 12 times x, so we're going to divide both sides by 12. And looks like easy peasy, 24 divided by 12 is going to give us 2. And those go away, so we get a value of 2 equals x, or if you really prefer, x equals 2. Both mean the same thing. Both ways to write it are totally fine. Okay, rinse and repeat. The good news is no matter what the original equation looks like, the act of checking it uses pretty much the same steps every time here. You're just plugging things in and hoping for the best. I suppose the one difference in this one is we've got to plug that value in once on both sides of the equations, but we're just following where the x is. So if we got an x value of 2, we're going to swap out the x's and put in a 2. Let's put that little question mark up there because we're looking to see if the solution checks out. Okay. I'm going to be a little more careful in this one. Negative 8 times 2, that will give you a negative 16. 4 times 2 is easy enough. All righty, here's where we're really going to see if we were correct or not. Let's do 7 minus 16. And when we do that, that's going to give us negative 9. And then when you do 8 minus 17, oh my goodness, we get another negative 9. Therefore, our solution is correct. Awesome. Great. All righty, time for the grand finale. This is really just combining what you had to do in the previous few problems. Notice that there's variable terms on both sides, but this time they threw some parentheses in it there. So you're just utilizing those same steps. It's just you don't always need every single one. So we got to get rid of those parentheses first. And notice there weren't any parentheses on the right-hand side of the equation. Therefore, we're just going to bring those down. From here, it's a lot like what you did in example 4. I would start with the variable terms. You could either move this term over to the right-hand side, or you could move this term over to the left-hand side. I'm going to do it the way that avoids a lot of negatives. So I'm going to add 4D to both sides. If you chose to subtract 3D from both sides, that would likely be fine. It's just your next few steps would look a little different than mine, but you could still come out with the correct answer. So let's see, those are going away. 3 dogs and then 4 more dogs come and chill in the park. So 7D, and then the 36 just came right down. We're getting there, you guys. Time flies when you're having fun, huh? Okay, this is our only variable term, which means now we have to work on moving the 36 over to the right-hand side. All righty, 8 minus 36, use a calculator if you need to. And we get negative 28. That looks very promising because I wasn't sure if this one was going to come out nice or not. Last step to get our solution, the opposite of multiplying by 7, is to divide by 7. Be very careful with your negatives. A negative 28 divided by 7 is going to give us a negative 4. Fantastic. So no fraction or decimal answers. Be aware though, especially when you're doing the assignment, occasionally you might run into a fraction or a decimal answer, but if you're not sure, if you think you did something wrong, feel free to reach out to your teacher and we will gladly clear that up for you. Okay, let's run through this check. Wherever there was a D in the original equation, we're going to swap it out and put in the solution we found. Okay, so swap out D, put in negative 4. Same thing over here. With my little question mark, which I often forget. All righty, let's see now. Again, you might feel comfortable doing multiple steps at once. I might not do that this time just because there's a negative in there. So negative 4 plus 12 will give us 8. Here's an 8 still. Negative 4 times negative 4 will give us 16. Now we just want to see if we get the same value on both sides. 3 times 8 gives us 24. And guess what? 8 plus 16 also gives us 24. Great. So our solution was correct, and we just proved that that's the case. Okay. Thank you again for your time, everyone. There should be an assignment for this set of notes on Google Classroom now. It should have been posted Tuesday, and this assignment will also be due on Wednesday. So you've got Monday's assignment and Tuesday's assignment that will be due on Wednesday. Please try to keep pace with that. Don't wait until the last minute before you do both of them. And of course, as always, please reach out to me or your specific geometry teacher if you are having trouble. Thank you for your time again. We will talk to you soon, everyone.